Welcome to EPG Pathshala. In this module, we are going to study different types of DACs. As we know, most of the quantities occurring in nature are in analog form. Output of sensors is also in analog form. It is found that processing, transmission, storage of digital quantity is easy. That's why we have to convert an analog signal into equivalent digital form. There are situations where we require to convert digital signal back into the analog signal because there are certain devices which can be controlled only by analog signal, and hence for such a situation we have to convert a digital signal back into the analog signal. There are different methods of converting analog signal to digital form or digital signal back into the analog form. The process of conversion of analog signal into equivalent digital signal are known as analog to digital converters. They are referred as either ADC or A to D converters. The circuits which converts digital signal into an equivalent analog form are known as digital to analog converters. There are again different methods of converting digital signal into analog form. It is found that DACs are the part of ADCs, and that's why in this module we are going to study first different techniques of converting digital signal into equivalent analog form. Digital to analog converter converts digital values to equivalent analog voltages. It performs operations which are opposite to ADC. It is found that in case of DAC, Vout is proportional to digital input values. In fact, as shown in the block diagram, DAC has got digital value as the input. By having suitable reference voltage, that digital values are converted into equivalent analog voltages. To convert such a digital signal into equivalent analog voltages, there are different methods. Primarily, there are two methods. They are known as binary weighted resistor method and the R2R ladder network. Besides that, there are two more modifications in these methods, and they are multiplier DAC, where reference voltage is constant and it is set by the manufacturer, whereas in case of non-multiplier type DAC, the reference voltage can be changed during its operation. As seen in the figure, the method which contains resistor values such that the value of each resistor is half of the previous value. This method is known as resistive divider method of DA converter. We see from the figure there are three resistors R0, R1 and R2. The bit at the digital input 20 is connected to R0 resistor. The digital data input 2⁻⁴ bit is connected to R1 resistor, and the digital input 2⁻²⁴ bit is connected to R2 resistor. The value of load resistor connected RL should be such that it should be very greater than R0. The values of the resistors used are such that the value of each next resistor is exactly half of the previous one, and that is why it is known as resistive divider method. We have to calculate the analog equivalent for different digital inputs. For this calculation, we are assuming that the digital input signal is 0, 0, 1, which is applied to this network, where we are assuming that 0 equal to 0 volt and 1 equal to +7 volt. For a digital input 0, 0, 1, the equivalent circuit can be drawn as seen. Since the digital input is 0, 0, 1, the voltage levels V1 and V2 are 0, and hence as shown in the circuit diagram, the equivalent circuit can be redrawn. For this figure, we can calculate the equivalent analog voltage VA. For the calculation of VA, we can use Millman's theorem. According to Millman's theorem, voltage at any node is the ratio of summation of current entering to the node to the summation of conductances connected to the node, and hence in equation form equivalent analog voltage VA can be written as VA equal to E1 upon R1 plus E2 upon R2 plus E3 upon R3 plus dot 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 divided by 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus dot dot dot. Applying Millman's theorem to this figure, we get analog output voltage VA, that is 7 upon R0 divided by these values, and which comes out to be plus 1 volt, which indicate that the contribution of LSB bit for 3 bit DAC having 0 equal to 0 volt and 1 equal to 7 volt, the output will be 1 volt. Consider the contribution of other bits. We can draw the equivalent circuit for other 7 combinations of the input, that is 0 1 0, 0 1 1 and so on up to 1 1 1. Applying Millman's theorems for these corresponding input combinations, we will get the table of voltages as shown. For a digital input 0 0 0, analog output voltage will be 0 volt. For a digital input 0 0 1, analog output will be 1 volt. For 0 1 0, it comes out to be plus 2 volt and so on, such that for a digital input 1 1 1, analog output will be plus 7 volt. Thus, to review the resistive divider circuit which is used for analog to digital conversion, it is found that for the conversion of digital data we require number of resistors. One resistor is required for one digital bit, that is if we have to convert 4 bit data into equivalent analog form, we require 4 resistors. Starting from LSB, each following resistor have a value one half the value of previous resistor. It is further found that the full scale output voltage is equal to the voltage assigned to logic 1 bit. That means, if we assume that logic 1 equal to plus 7 volt, full scale output will be plus 7 volt. If we assume that logic 1 equal to plus 15 volt, full scale output will be plus 15 volt. It is further found that in case of resistive divider method, LSB has a weight of 1 upon 2 raised to n minus 1, where n is the number of bits in the digital data. This resistive divider method has got certain advantages as well as disadvantages. The first and very important advantage is it has got very simple construction and hence the analysis becomes very easy. The second advantage is it has got fast conversion. However, method also has got certain drawbacks. The first drawback is practically it becomes very difficult to get the value of each resistor exactly half of the previous one. This method requires large number of resistors and the ratio of values of the resistor will be from 2000s to 1 for 12 bit DAC. It is found that practically it becomes difficult to get the value of resistors exactly half of the previous one, and naturally this method has got less precision due to different value of resistors. Since MSB resistor has to handle large current and hence there is a restrictions while choosing the value of MSB resistor, since this resistor has to handle large power. There is a second method of conversion of digital signal into equivalent analog one. This method is known as R2R resistor ladder network. This is known as R2R network because this method uses only two value of resistor R and 2R. For this method, the output voltage is properly weighted sum of digital inputs. Since it is constructed using resistors having only two values and hence precision is more. Let us consider ladder design for 4 bits. As seen in the figure, the 4 bit DAC R2R method of conversion requires 8 registers, out of that 5 having value 2R and 3 having value R. From figure we can see that the terminating register has value 2R. This network also has a unique property. It is found that from the node A, B, C or D, looking towards the terminating end or towards the digital input, the impedance is always 2R. To analyze this R to R network for various digital inputs, let us assume that digital input signal is 1 0 0 0. For this digital input, this figure becomes, for a digital input 1 0 0 0 where MSB bit is 1 and all other bits are 0, the equivalent circuit can be drawn as shown. From the equivalent circuit we can calculate equivalent analog voltage VA, since it is a potential divider arrangement with a voltage source plus V, voltage at point D which is analog voltage VA, it will comes out to be plus V by 2. That is, the contribution for MSB bit in case of R to R method is plus V by 2, where plus V volt is the voltage assigned to logic 1 bit. We can determine the output due to second MSB. For that purpose, let us assume that digital input is 0 1 0 0. This can be represented by the circuit as shown. From the circuit we can see that to the left of node C there is no voltage source, and hence entire circuit to the left of node C can be replaced by a single resistor to R, and hence equivalent circuit becomes, since there is no voltage source to the left of node C, the entire network to the left of node C can be represented by resistors of 2R to form the equivalent circuit. The final equivalent circuit is as shown, and from this circuit we can calculate the output voltage VA, and as seen it comes out to be plus V by 4. Thus, contribution of second MSB at the output is plus V by 4 in case of binary ladder network. Similarly, we can calculate the equivalent analog output for different digital combinations. Table shows the output voltages for different bit positions. From table we can see that MSB bit has output voltage plus V by 2, contribution of second MSB is plus V by 4, third MSB is plus V by 8 and so on. The nth position bit will have binary weight 1 upon 2 raised to n, whose contribution at the output will be V divided by 2 raised to n. Let us review the resistive divider method. This method basically is a composed of linear component. The principle of superposition can be applied in order to calculate the contribution of digital bit at the output, and the total output voltage is the combination of input digital signals, which can be found by taking sum of output levels caused by each digital levels individually. Thus, in equation form, output voltage is given by as shown in this equation. This equation can be further simplified to the general form as VA equal to V0 into 2 raised to 0 plus V1 into 2 raised to 1 plus dot 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 Vn minus 1 into 2 raised to n minus 1 divided by 2 raised to n, where V0, V1, V2 are the digital input voltages and n is the number of input bits in the digital data. This equation is very useful to calculate output voltage from the ladder by any digital input signal. DAC methods used for conversion of digital signal into equivalent analog signal has many practical applications. Whenever we have to connect load to such a DAC method output, it is found that there may be loading. To avoid the loading effect, we can connect output of binary ladder method to operational amplifier. As seen, operational amplifier is used as a unity gain non-inverting amplifier, which is known as buffer. Basically, it is used to avoid loading. As we know, operational amplifier has infinite input impedance and hence current drawn is ideally 0. Thus, even if we connect any load to the output of binary ladder or resistive divider method through such a unity gain amplifier using op-amp, loading effect is avoided. The digital input used in case of binary ladder network may be a voltage source or it may be a current source. Figure shows the circuit diagram where current sources drives the binary ladder network. It is found that precision obtained in case of current source based binary ladder network is more as compared to voltage sources used as a binary data input. We have seen two methods of digital to analog converters. Each method has got certain pros and cons. As far as binary ladder network is concerned, it is found that it can be very easily understood and it uses only two value of a resistor. The implementation of this method is quite easy. It is easier to build the circuit, to manufacture the circuit, as well as it has got faster response time. But when we consider disadvantages of resistive divider method and the binary ladder network method, it is found that resistive divider method is usually limited to only 8 bits, because as the total number of bits increases, we have to use large number of resistors which are more susceptible to noise. The circuit becomes more expensive and it has got more noise or the error. The only disadvantage of binary ladder network is the analysis is little difficult. Digital to analog converters has got many applications. The first one is generic use. It can be used in various circuit components. We may require digital audio where DACs are required. Digital function generators, digital oscilloscopes also requires DACs. Motor controls, valve controls can be done very precisely using digital to analog converters. Let us see the generic application of digital to analog converter. Whenever we require a continuous analog signal from a digital input, we can obtain this using DA converter. As shown, we have a n bit DAC which has got n digital input 0 to nth bit. The output of DAC is not continuous one, but it is piecewise continuous. We will get certain noise and that noise can be filtered in order to obtain continuous analog signal that may be used to drive the pen recorders, to control servo motors and so on. There are certain circuit components which also uses digital to analog converters, may be voltage controlled amplifiers, a digitally operated attenuators, or there are even programmable filters whose cutoff frequencies can be designed, can be controlled from digital input. Digital to analog converters also finds applications in digital audio, where rather than storing analog signal which is more prone to noise, nowadays data is stored digitally in CD players, MP3 players, as well as in digital telephone and answering machine. The commonly used instruments in the electronic laboratory, such as digital oscilloscopes, requires digital input and analog output. Even signal generators will have digital control, and depending upon digital input we can generate sine wave, square wave, triangular wave from signal generators. DACs also finds application in motor controllers, where we can control very precisely the speed of motors, its direction by controlling digital data. Few examples are the cruise control, the wall control and the motor control. Let us summarize this module of different methods of DAC. As seen, DAC converts digital signal into equivalent analog signal. There are different methods of DAC. The first one is resistive divider network. In case of resistive divider method, we have to use the value of resistor such that the value of each next resistor is exactly half of the previous one. If LSB resistor is R0, second LSB will be R0 by 2, R0 by 4, R0 by 8 and so on. Practically it is found that it becomes difficult to get the value of each resistor exactly half of the previous one. Further, the MSB resistor has to handle large current and hence this method is more prone to error or normally not preferred. And that is why the second method of DAC is developed, which is known as binary ladder network. This method uses resistors of value only 2's. If one resistor has a value R, the second resistor will have 2R. It is found that for 4-bit binary ladder digital to analog converter, out of that 8 resistors, 5 will have value 2R and 3 will have value R. Uses resistors of value R and 2R, only 2 different values. Naturally, the drawback of resistive divider gets suppressed. In fact, current handled by all input resistor is also same and hence it is found that binary ladder network method is more easy, normally used for conversion of digital signal into equivalent analog one. Such a DAC outputs may drive certain load, and to avoid the loading we can connect output of DAC to operational amplifier, which is used as a buffer. Op-amp can be used to avoid loading while driving digital signal into a source. Such a DAC has got many applications. It is used in circuit components, it is used in devices, it is used for motor control applications, as well as it is also used in the circuit components. Thank you.